day is to say that functions are just like anything else. Well, great. How do we return functions from other functions? So to do that, we're going to talk a little bit. We're going to go through a few cases and then talk about something called closure, which is going to be very valuable for you to know as well. So here we have a function. It returns a string on line 7 there. When we run that function, when we actually invoke it, returns a string. It's going to give back I am a string, and we capture that value in return value, right? And remember, the reason why we are capturing it in return value is because a function always returns its value to wherever it was called, right? To whoever asked for it. So in this case, we asked for it on the, I guess, right-hand side of line 7, and so that's where we return the I am a string value to. So then if we take that corollary if we take that concept and we extend it to functions, well, same exact idea, right? On line 1 we have a function called greetMe. On line 5 we have a function called getGreeter, and it returns the greetMe function. Notice how it's returning the greetMe function. Where so one is right as a common note, we're returning the function, right? Up until line 8, do we ever invoke greetMe anywhere? No, right? We never see greetMe followed by an open and closed parentheses except when we're defining it over there on line 1, right? So sorry. So on line 6, when we return greetMe, we're not returning greetMe after it's been invoked. We're literally saying, here's a function. I don't know what it does. In fact, I don't even know it's a function. It could be anything. I'm just going to return it to you, right? It's just a variable at that point. Line 9 is where we actually invoke getGreeter on the right-hand side. And when we invoke getGreeter, what does that return? It returns the greetMe function. Bless you. And so now on line 9, greeter becomes the greetMe function, right? Does everyone see that? After line 9 runs, getGreeter on the right-hand side is going to return the greetMe function, and then on line 9, greeter is going to equal the greetMe function. So on line 11, when we console log out type of greeter, we get function. When we console log out greeter, we get function greetMe. And then lastly, when we console log out lastly, when we invoke greeter on line 13, it's just like we're invoking greetMe on line 1. Right? So this is just a purely an extension of this idea that, hey, before I could pass a number or an array or whatever back and forth and use it as if it was a number or the array. Now we're saying we're passing a function back and forth, and we're able to use the variables like as if it was a function. Anyone not clear on this? If not, the workshop is going to be very, very painful. Like, anyone not clear on these things? Yeah, Megan? You're not clear on which part, I guess?
So why would you want to return the function without calling it? I guess it's
Yeah. Well, because I may want to call it somewhere else, right? Like on line 9 there, if I have a greeter function, I may say, hey, I want to return this at a later point. I want to invoke this at a later point in time. Or I might even want to pass it somewhere else. You're right that in this case, it makes a little bit less sense because greeter and greetMe are both on the same scope. So wherever you could use greeter, you could probably use greetMe. But we're going to see a few examples where we kind of go between scopes, and this matters a lot more. But I guess, like, intent aside, like, does the operations of this make sense, everyone? Like, you can tell like how we are able to do all these things, right? Like, there's nothing really even new here, right? The only difference is we're just using functions instead of normally where we would use like an array or a string or a number. Yeah, Josh?
Line 12, the way that it prints function : greetMe.
Yeah.
Is there ever a way you could do like log greeter and then actually see the code print out? As opposed to just the name of it?
I don't think so. I don't know of any easy way. There might be. I just don't know of any way to do it. Yeah. Also, one more thing to notice here. On line 6, when we return greetMe, like, notice how like that kind of very elegantly pulls from our scope conversation last week, right? Like on line 6, when we say greetMe, well, where do we start looking for greetMe first? We start in the getGreeter scope. Like, great, do you have a greetMe function? And the answer is no, we don't. Well, okay, so do my parents, which is the global scope, have a greetMe function? And we do. It's there on line 1, right? So that's where that greet me function comes from. With the scope, remember, we always start inside and we can look outwards, but we can't start outwards and look inside. Okay, so now we're going to kind of go to the opposite, the kind of the other example of that, which is, okay, with now on line 6, instead of returning greet me the function, we're actually going to return whatever greet me returns when it invokes. Okay, so here when I look at line 9 now, I still invoke getGreeter on the right hand side of the equation, and what getGreeter does is when we invoke getGreeter, it returns greet me invoked, right? But in order for us to know what we're returning on line 6, what do we got to do?
What was the question?
How do we figure out what value gets returned on line 6?
Call greet me.
Right? Yeah, we invoke greet me, right? And so on line 6, we're invoking greet me first, seeing what it returns, and then returning that value. Before, we were just returning the function greet me without invoking it, so we had no idea what it did. Now we kind of have to run that function first, figure out what it gives us before we can move on to the next step. So when we invoke greet me, it's going to console log out hi, which we see on the right hand side. It's the first line. And then what does it return? It returns back undefined, right? Because there's no return statement in the function. And by definition, all functions in JavaScript return undefined if we don't give it an explicit value to return. So now, if we say that greet me function here returns undefined, what does this become? Undefined. And so then when getGreeter goes here, we're actually saying is return undefined. So where are we returning this to?
getGreeter.
Where? Which line number?
5.
Nope. Where are we returning this to?
Oh, greeter on line 9.
Line 9.
Yeah.
This becomes what?
Undefined.
So what does greeter become?
Undefined.
Undefined. And that's what we see here, right? We see hi. We see the undefined because we're console logging out what the type of undefined is. It's going to give back undefined. We then console log out what greeter actually is, which is undefined. And then you can't really see the text here, but what you're going to see here is when we try invoking greeter, and we're going to get an error saying type error, greeter is not a function, which makes sense because greeter is undefined and we can't invoke an undefined. Okay? This is just to show you that, well, this is highlight two concepts. One, before we could blindly return back greet, right? We didn't care what it did. But once we invoke it, we can't be as callous anymore. We have to actually figure out what greet is returning before we pass on to the next, or to whoever called it. And secondly is that, once again, all functions in JavaScript is going to return something. You're never going to be without a return value. The only question is it something that, is it what you want, and is it something that you can use downstream? Any questions here? Okay, yeah, and I can't stress this enough. Like when you're doing the workshop today, like just be very, very, very honest with yourself. Even if you don't know the answer, like test, like console log out, run things, figure it out. Don't just assume that whenever you see a function that it's going to be run or it's not going to be run, right? You want to be very, very clear in your mind about what the distinction about at each value, what it is. Because once again, greet me is a function. Greet me invoke is undefined, right? And how you use that is going to be, it's going to be worlds apart downstream in your code. Okay. So here is where things get really, well, this might not look interesting, but there's something here that's like actually extremely powerful. So here we have a function called getGreeter. If we were to run getGreeter, right, it does all of this. Well, let's just skip lines 1 through 9 because nothing's running, right? We're creating a function. Between lines 1 through line 9, we haven't run anything yet, right? Line 10 is the first time we actually run it. We say, like line 10, it wants to create this variable called greeter, and it's going to equal to whatever getGreeter returns, right? It doesn't equal getGreeter, it equals whatever getGreeter returns, right? So super key distinction here. So this requires us to actually do what? We actually have to run getGreeter and figure out what it returns, right? If these open and closed parentheses weren't here, what do we do? Yeah, we just say, here you go, here's a function. What does it do? I don't know. I don't care, right? You asked for the function, here it is. Now with this open and closed parentheses here, now the question becomes, all right, I can actually run it first and figure out what it's going to give me, so I can then hand it back to someone else, right? So this requires us to actually run get greeter. We go back to line 1 now. We look at get greeter. We start top down. Okay, we see on line 3 through 5 we create this function called greet_me. Haven't run it yet. And in fact, on line 7 we see return greet_me. So up until now, have we ever run greet_me yet? No, greet_me up until line 7 has never been invoked. Right? It's just saying, here's a function. What does it do? I don't know, but here you go. Right? This is what we asked for. And so then because of that, we return greet_me. Right? So what does this become? I'm sorry. Which function? Yep. So this right hand side becomes the greet_me function that got returned from getGreeter, and so greeter becomes what? So now greeter becomes greet_me. When we run greeter down here, we get back console I got high, because when we run greeter, it's almost the same as running greet_me. It's the same as running greet_me. Yeah, Jake?
So just like a simpler way to say all that, like pretty much all this is doing is renaming things, right? Like
It's
essentially like you're
it's
saying
less renaming things. It's more like, you know how like,
assigning things, I guess.
yeah, it's more like we're creating more variables to have a reference to that thing.
Right.
Right. And so, okay, so why is this really, 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 really important? Like when you look at this code, when you look at the getGreeter function, what are we doing here that, I'll give you a hint. Like 30 seconds ago, I said you can't do.
You can't not have a return statement in a function.
Running a function out of the scope of.
No, we could or could not have a return statement in the.
Oh, you just got
Yeah, if we don't put it in there, it'll just return undefined. If we do, it'll return whatever we tell it to return, right? So that's always been an optionality. If anything, like so we can never have a function that does not return anything. It always is going to return something. Sorry, what were you saying, Jake?
We're running a function like out of the scope of another function. I don't know if I said that right, but does this have to do with scope? Like, is that what you're getting at?
Yeah, are you looking at the slide or?
Yeah, I'm looking at the slide right now.
Yeah. So one of the things.
Oh no, I'm looking at the slide you have up right now.
Okay. One of the things on this. So yes, pretty much right. Like one of the things here that we're doing here that we previously had never done before is greet_me is essentially a what? It's a function, but it's also just a variable, right? And now what I'm doing here that's really kind of powerful is I have a variable. I create a variable called greet_me in the getGreeter scope, but I'm able to use it on line 11 there, outside of the getGreeter scope. Right. So remember I said 30 seconds ago, or I guess 2 minutes ago now, like scopes can start inwards and look outwards. It can't start outwards and look inwards. But here on line 11, I'm actually able to kind of look inside the scope of getGreeter. And so this is oh yeah, and sorry, quick sidebar. We can also do this with anonymous functions. You don't need to give the function a name. Same idea. Nothing too fancy. Sorry, I should have covered this before I jumped into the next topic. But before we created greet_me, the greet_me function equals this, and then return greet_me, or we just say return this function directly. It does the same exact thing. No difference.
Right.
It's just like in the previous for each slide, we talked about how you could either name a function and then pass it into for each, or you could just pass it define the function in the for each parentheses itself. Same idea here. Yeah, Histe?
But with anonymous functions, you're not, when you're doing the return for this one, you're not returning an invocation of the function. You're returning.
Well, in the previous slide, we were not returning an invocation function either.
Yeah,
So,
so the question is is there a way to use an anonymous function and return an invocation of the anonymous function, or is it just for returning?
you literally just put an open and close parentheses after that.
Okay.
You're just invoking it, right? It's just rather than calling it one variable, you just kind of call it by itself. It's a little more complicated to put it in the parentheses first and then put open and close parentheses after it, but it's doable. It's just like the syntax is like a slight tweak to it. Okay, so anonymous functions we are also able to return, so we can treat those just like normal functions. And then lastly, the idea here is that those functions, guess what? They're functions, right? So they can also take in arguments, and they can also return other things too. So here's just an idea. So here's an example of where this anonymous function is built in to take a name. So once we return this function and greeter becomes this function, when we invoke greeter, we also pass in a name, and it's the same as passing the names up there.
I have a question.
Yep.
So is there situations where you'll like solely make a function that has another function just so you can use it, like globally? Or is that just for these examples? That's just how it comes off. Like if you knew ahead of time what you were making, and like you knew that you had a function that you were going to need to use like a bunch of different. I don't even know if I'm wording my question right. To be honest, never mind.
Yeah.
I'm just gonna. Never mind. Just forget it.
Okay. Cool.
I'm just thinking too.
Okay. So now we're gonna actually kind of segue back into this idea of closure, right? So before we were saying, hey, guess what? In this case, this code works perfectly fine because in the says hi function there on line 8, when we actually run says hi, we're gonna look for a name. We're not gonna find it in the says hi scope. We're gonna say, okay, let's look. Is it in my parent scope, which is greeter? Is it in greeter? Yep. There's a name called Marie, so we're gonna use that name. And so when I console log out hi name, I get hi Marie. But the idea of closure here is when I return a function, right? Not only am I able, so maybe this answers your question a little bit more, Jake, of why we would ever do this.
Right.
Not only are we creating a variable that we can then return to be used outside of this function, right? So not only are we creating a function that we inside getGreeter that we can use outside of getGreeter, this function has access to what scope?
The getGreeter scope.
It has access to the getGreeter scope. And so if I use this function outside of getGreeter, I now have access to the things I have access to the same scope that function has access to, which is a getGreeter scope, right? And so how that looks is this. Here on line 8, I return, line 13, greeter equals getGreeter invoked. So let's invoke getGreeter. We have 2 console logs. We create a variable called name, and we assign the value of Marie, and we return a function that console logs out hi, comma, name, right? So when we return this function, we don't invoke it just yet. This is just a function. On line 14 is when we actually invoke this function.
Mm-hmm.
And when we invoke it, we get back hi Marie, right? And so the reason why that is because when we invoke greeter, even though we're outside of this getGreeter scope, this is actually invoking this function, and this function has access to the scope. Remember, scope is defined when you're created, right? So when this function was created, it had access to all the variables inside the getGreeter scope, if you will. And so when we use, when it looks up name, it's actually looking up in its own scope first, which doesn't exist, right? There's nothing in this function called name. So then it goes to this parent scope. Who's his parent? Its parent is getGreeter. Is there a variable called name? Yes, there is. It's called Marie. And so now on line 14, even though we're technically outside of the getGreeter scope, we're still able to use that function to access variables inside of the getGreeter scope. Yeah, Jake?
Wouldn't it just be more like logical to just return Marie or like hi plus name?
No, because what if I don't like on line 13, greeter becomes that function, and I'm invoking on line 14. What if I wanted to like invoke what if I wanted to run other code in between it? Right. So the reason why we create a function is because a function is not only able to pass back and forth, we can actually reuse it different times.
Mm-hmm.
And the other thing that's slightly different here that is a bit of a nuance. It's that we can create multiple versions of the same function. And so that's something that you'll do in your workshop today, or you'll get a sense of doing in the workshop today. But for now, just kind of like the important part of this is this idea of closure, right? And so what do we mean when we say closure? It means when we create this function, it actually encloses on the scope that it was originally created in. So no matter where we take this function, we could pass it in 10 other places, and it will always have access to this scope, or to the scope of the getGreeter function.
Oh, because it's originally inside.
Yep.
There.
Yeah. So getGreeter, once again, scope is based on the point of creation, right? And so because this function was created on line 8, it was like, who do I have access to at this point? Oh, I have access to the getGreeter scope as well as my own scope. And so no matter where this function goes, it will always keep track of. It will always have access to that getGreeter scope. Yeah, Josh.
Just to be clear, it would have access to it, and line 4 would take precedence over a global main variable declaration.
Right, because once you run the code, it will say, do I have it in my own function scope, lines 8 through 10? The answer is no.
There first.
Yeah, and then it'll check lines 1 through 11. If it doesn't have it there, then it'll check the global scope because that's the next level up.
But doesn't global scope override local scope, or never? Do I have it backwards?
Quite the opposite.
So okay.
Global scope is always the last resort. It's the last backup.
Okay.
Your local scope always takes precedence. Okay. And then this part, quite honestly, not as interesting. If you just kind of follow through this code, you'll see getGreeter takes a name, so it takes a name, and the whole point is to show you that, hey, remember how we talked about like maybe 4 days ago? Parameters are just variables. Well, here inside this function, you have access to everything inside the scope, which includes all of the variables you create inside of it, and also all of the parameters that are passed into it. Really quickly, one distinction here. I use arguments versus parameters. I try to use them in the right order, but just so you know, arguments are what you call the things that you pass into a function, and then once you're inside that function, parameters are what you call those things once you start using them inside the function, right? So in this case, Rosalind is the argument. Name is the parameter. Even though they're kind of pointing at the same thing. Like when I use those words, like that's what they mean, right? They're pointing to the same thing, but argument is what you call the thing that goes into the function, and then once you're inside the function, it's called a parameter. Right. So once for this function here, between lines 3 and 5, when we create this has access to everything inside the getGreeter scope, which includes all of the function's parameters, because they are also just variables that are part of the function scope.
So now you can just pretty much call greeter whatever that you wanted to say hi to somebody.
Yep, you can call hi Rosalind. The only difference here, and we'll see this probably more closely in the next slide, is greeter can only say hi to who?
Rosalind.
Right. Greeter can only say hi ever to Rosalind, right? Because once we run this, once we create this function, as far as this function is concerned, what is name equal to?
Rosalind.
Now and forever, it will always be Rosalind. Right?
Or if you use greeter.
Yes, for user greeter. So on the next slide, we're going to see an example of, well, this one's not the best example, but here the idea is, well, what if we have name one up here, but the function itself also takes in another name. So now when we make greeter, our initial greeter is Marie, but now we can call greeter, we can call it for Rosalind, and so it'll say hi name 1, which comes from the parent scope, but name 2 is going to come from its own scope, if you will. All right, so we can really easily kind of combine these two ideas here. Still good with everyone?
Can you just leave it up for a second?
Yeah, that one's a little. I don't know what I'm having
Yeah. So this is the same as the last slide, except here we have name 1 and name 2. Name 1 comes from the parent scope,
Right.
and then name 2 comes from the function of whatever we invoke it with.
Okay.
So basically, after line 8, greeter is going to be a function that's always going to say, hi Marie, meet blank, right? And then when you actually invoke greeter, whoever you pass in at that point will be that blank.
Okay.
So if on line 10 I wrote, greeter invocation with Jake, it will say hi Marie meet Jake.
Okay.
And then after that, hi like greeter in parentheses David, it will say hi Marie meet David, right? So I've kind of fixed the first name because I fixed name 1 because it's coming from my parent scope,
Right.
but I have the optionality of taking whatever value you give me for name 2.
And
Oh, sorry, go ahead, Josh.
So is greeter is kind of like get greeter parentheses Marie parentheses Rosalind. What would that look like if you broke it out?
Sorry, say it one more time.
Greeter.
Yep.
Line 9.
Yep.
If you were to break it out, it's kind of like get greeter parentheses Marie function parentheses Rosalind.
Yeah.
Like in terms of syntax, looking at greeter with parentheses Rosalind, I can't clearly see how that gets passed into name 2.
yeah, that's a good way to ask.
I get that it does, but it seems like I just have to memorize that, not like actually think it through because I can't see it.
Yeah. Yeah, I totally get how name 1 would be always Marie.
Okay, so after we run this, greeter is equal to
Oh, I see it. Thank you.
how do I make this smaller? Does it make sense, everyone? When I run getGreeter, what does it return?
Oh, function name 2. So is it just, it's because you have return there, so you're returning the function with an empty, like, okay, alright. I think I got it.
And then the argument just replaces name 1.
Name 2. Sorry,
Marie.
the argument to getGreeter replaces name 1, and then
Yeah.
and then whatever you invoke greeter with replaces name.
Because
Yeah.
the return value is the function.
Yep.
Got it.
Remember, after we run line 7, have we invoked this function yet?
No.
We've never invoked that function yet, right? We only invoke it here on line 12 for the first time ever.
Right. Because getGreeter just returns that function.
Right. So
You're not doing anything with it.
exactly. So this is the distinction between returning a function versus returning the invocation of a function.
Okay.
Cool. All right. So I think we have to go 2 more slides here, and then we're done. What?
I just said I was a little hot.
Okay, so this is the last slide here. This is conceptually the same as the last slide. Like the function looks identical. The only difference here is just we kind of understand why our functions are a little bit a lot more flexible. But also notice how on line 7 and line 8. On line 7, we're invoking getGreeter, right? And we're getting back a function. So introduce Marie to is a function. On line 8, we invoke getGreeter again, except this time we pass in a different name. We pass in Rosalind, right? We get back a function that thinks that name 1 is Rosalind, and we store that under introduce Rosalind to, right? And so this is another reason why I mean, it's not the best explanation, but it's like this is a reason why like when we pass these functions, it's incredibly flexible. Is because in this case, we're actually creating multiple instances. We're running getGreeter multiple times, and each time we're doing it, we're creating a new scope with a new name 1 variable, right? So name 1 to introduce Marie to is different than name 1 for introduce Rosalind to. Cool. right? And so a lot of times you'll see this with like with classes, for example. Like when I make one string, even though it's a string, it's different. Like like string Jake is different than string Julian. They're both strings, right? They have a different like Jake dot length is different than Julian dot length, right? Now, Jake index 0 is the same as Julian index 0, but like the idea, like even though they're the same thing, when I can create two copies of it, and each time it will have a different set of parameters, right? And so now when I run introduce Marie to and I pass in a name, that function can only introduce people to Marie. Similarly, when I run introduce Rosalind to, it can only introduce people to Rosalind. One question is, well, geez, like, wouldn't this be less flexible than just taking two arguments and kind of building out from scratch? And the answer is, if that's our goal, then yes. But a lot of times, you actually want this kind of memory. You want this function to only work for a certain scenario, right? So an example would be, and this is a really bad example, but like example would be like if I was logging into Facebook, right? And Facebook says, "Oh, here's a function for you to get all of your photos." Facebook will want to get me that function and set that function up in a way that I can only get my photos, right? Like I can't get Jake or Julian or Liddy's photos, right? So there might be a property called whose photos, like David, right? And so when I use that function, I can use it as often as I want, right? But I can only use it with that particular name or that particular user, right? Facebook does not want to give me a function that says, "Hey, fill in a name and you can get their photos automatically." It's like, no, you can only get this person's photo with this function, and I'm only going to give you this function. So it's also very safe too. You kind of can tell this function to remember certain things. Could you hard code it? Yes, but then when you create multiple copies of it, it gets really hard really quickly, right? So that's why we kind of build versions of functions with certain values that are hard coded. Yeah.
So this would be
Puberty.
Yeah. I'm like just finishing up. So you'd be using you'd use this sort of like method to things when you specifically want to do something specific to something. Like rather than like let me explain that. Rather than putting like get greeter name 1 comma name 2 and then literally just returning hi name 1 meet name 2, you want to just like I think I'm actually having a hard time differentiating when you would do that in this. Like wouldn't it be way easier to just type that rather than have to run through two functions to return that?
Sure. So a bit of a contrived example, right? But let's say like there's a class of let's say 20 people here, right?
Mm-hmm.
And let's say I want to give each of you a function that introduces yourself to companies at a hiring day, right? I could give you a function that takes in your name plus the name of the companies, but then that would mean you could impersonate someone else.
Mm-hmm.
Like like hi Google, like I'm Ariana, right? So you could impersonate someone else. Instead, what I do is I give you a function in which your name is stored, and you can only put in the name of the company, and it will always say, "Hi, whoever, I'm Jake." Right? So in that case, like I can use that function to create a different version of the greet function for every single person in this room, and now I have a much greater level of control over what that function can and can't do. Right? So once again, a bit of a contrived example, but
also
but
without having to write the same function.
exactly.
20 of the same functions.
Right. So now when all of you need to greet 10 companies, right? You don't need to keep writing hi, name 1 Jake, name 1 Jake, name 1 Jake, name 1 Jake. It's like hi Google, hi, Facebook, hi whatever, right? And you just kind of go through that. So another part of programming and with functions especially is, like I said, in the workshops that we do, we tend to write functions. We tend to write one function that tend to do a lot of different things. In the real world, people actually want functions to be as small as possible and to do one specific thing really, really well. And so because of that, you don't want functions to know any more than they have to. Like you want functions to know the bare minimum to do their job, right? It's like if you're an entry-level employee at a company, right? Like your CEO is not going to give you all the internal financials and all this excess data if you don't need to do your job, right? Like he or she will tell you the bare minimum you need to do your role, and then you do it, right? And so with functions, the same thing. Like when I give someone a function, a lot of times I may have like a lot of logic underneath it, but I don't want them to see it. So a real world example is a while back I was building I was building something that like looks at certain websites, right, and gets data via an API. Which basically think of it as a almost like a service station. Like I go there, say, hey, like if I was to go to like a sports site's API, it's like give me the record for the Cubs this year, right? Give me the record for the Cubs this year. Well, in order for me to be able to ask them that question, I need an account with them, right? I need to have a certain account with them so that they'll give me back the answers that I want. Now, when I make the request, what I don't want is I don't want to have to say, hey, like, what's the Cubs? By the way, here's my username and my password and my token, right? And in fact, when I want other sites to use it, I don't want to attach that information along with it. I just want to make a function that says, hey, what's the score of the Cubs or the Bears, right? Or the Padres or something, right? And that function, through its scope, has access to my credentials, but the end user never sees it. Right? So that's an example of where like I would want a function to have access to things that I don't want the end user to know about, and so I use that, and it kind of works out that way too. So once again, like these are not like the perfect examples, but conceptually you can hopefully get a sense of like a lot of reasons why people do this is because I want a function that does one thing really, really well, and because I know I need to do this one thing over and over again. I don't want to have to keep type out the same thing over and over again.
Right.
Cool. So that's pretty much it. Returning functions returning functions from other functions, and the idea of closure, which is once again, scope is determined based on where something is created, and so closure is this idea that a function has access based on where it was created, even when that function leaves that particular scope, it still has access to that scope, right? Like its scope kind of encloses over the scope in which it was created in. All right, any questions? Yeah.
Does higher order functions just refer to functions within functions?
Yeah.
Okay.
Yep. Any other questions? Cool. All right. Well, it's now 3:30, so we're just going to work on this workshop from now to the end of class.